Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Paper 1 Foundation Tier from 2025. Question number 6 is on the topic of energy. Figure 10 shows a toy which is hung by from a support. When the handle is pulled down and then released, the toy bounces up and down. We have a spring with a toy support with the handle. When the handle is pulled down, the spring extends. The extension of the spring is 0.35 meters. The spring constant of the spring is 5.5 Newton per meter. Calculate the elastic potential energy stored. So they have given you the equation. Elastic potential energy is 0.5 multiplied by the spring constant is 5.6 multiplied by the extension is 0.35 squared. That gives you 0.343 joules. Use the physics equation sheet to answer the questions. Which equation links gravitational field strength, gravitational potential energy, height, and mass? So, gravitational potential energy equals mgh. Mass, gravitational field strength, and height. When the handle is released, the toy moves up through a height of 0.6 meters. The toy has 0.294 joules of gravitational potential energy at its highest position. Gravitational field strength is 9.8. Calculate the mass of the toy. So, E equals mgh. So, 0.294 equals m times 9.8 times 0.6. M equals 0.294 divided by 9.8 times 0.6. So the mass of the toy is going to be 0.050 kilograms. Figure 11 shows the toy in 3 different positions, A, B, and C. The toy is released from position A and moves upwards. The toy is moving upwards in position B. The toy's maximum height in position C. Between positions A and position B, the extension of the spring decreases. How does the elastic potential energy store of the spring change as the extension decreases? The elastic potential energy should actually decrease because it's not being stretched. Instead, it's been converted to GPE. Between position B and C, the toy slows down. How does the kinetic energy of the toy change as the toy slows down? The kinetic energy should actually decrease if it's slowing down. How does the gravitational potential energy of the toy change as the toy moves from position B to C? Gravitational potential energy should actually increase. The toy moves up and down many times before eventually stopping. Which two of the following are reasons why the toy eventually stops? Air resistance opposes the motion of the toy. That would be correct. Energy is destroyed. No, energy is transferred to the surroundings. Yes, that's thermal energy. That brings us to the end of question number 6, and I will see you in question number 7.